So for problem 1, I have to plot an R versus energy graph of two electrons which start out some distance apart and at rest. The potential energy varies with 1 over R, and because the electrons start out at some distance apart, the graph only shows from R initial to as R approaches infinity. Since their initial velocities are 0, kinetic energy starts at 0, and it counters the potential energy so that the sum of energies is some constant value, some positive constant value. In problem 2, I have to graph on the same plot of a comet approaching the sun from far away that does not collide or orbit the sun. The potential energy in this scenario varies with negative 1 over R. Because the closest it gets, because it does not collide with the sun, there has to be some shifting, some minimum radius that approaches, and that it can be from infinitely far away. So that's why it does not actually go all the way to R equals 0. As I said, the gravitation varies with negative 1 over R, and the kinetic energy is used to counter the potential energy so that energy is some constant value throughout it. The total energy is the sum of all energies. And it will have a positive value as it approaches of infinity because the comet is going to continue when it's infinitely far away with some velocity, so the kinetic will be positive as well. So total energy has to be positive because it's the sum of all energies. Finally, for part 3, I have to do a spacecraft leaving Mars with an initial velocity that is below the escape speed for Mars. Again, this is segmented for only part of it. There's an R min value because the spacecraft is not actually leaving from the center of Mars, rather it's leaving from the surface of Mars, and it doesn't go to infinity because the initial velocity is below the escape speed, so it will not actually make it out of Mars's atmosphere. The potential energy varies with negative 1 over R and has to be shifted downwards because the total energy is negative, as that is the definition for not having enough escape speed to leave. And the kinetic energy, again, starts at some value and approaches 0 so that it counters the potential energy so that total energy is constant. And before it escapes, it loses all velocity and thus gets pulled back to the Earth's surface by Mars' surface by gravity.